new father, and really, really good about ones and zeros going really, really quickly. And you have your own set, so please take it away.
Thank you. Whoa, that's an echo. Yeah. Um, yeah, so I'm here to talk about DevOps, turning Dev and Ops into DevOps. Actually, this is a talk about productivity, I think. But in order to get to the parts about productivity, I'm first going to have to talk about scalability, availability, Dev and Ops, and about 15 years of history of our industry. So I work at a company called DICE. We make games, the latest of which is this. This is Star Wars Battlefront 2. It will be out in a few weeks, and if you're into this kind of game or Star Wars in general, play it. It's amazing. It's like being back in the 70s Star Wars. So it's absolutely fabulous. So what do I do at DICE? I actually started out as a backend developer. I've led the DICE distributed systems teams, and what that team does is things like matchmaking, leaderboards, player statistics. For example, we track every single bullet you've ever fired with an AK-47 as a time series. The reason I'm talking about productivity today is because when you work as a developer and when you lead developers, you're going to figure out that there is a force multiplier when it comes to good tools and great infrastructure. So if you have great infrastructure, you can have engineers that are not twice as effective as other engineers. I would argue that you can have magnitudes more productive engineers if you have great tools. So this talk is really two talks. The first one is called From Products to Services, and that's the Dev and Ops to DevOps part. That's essentially the 15 years of history. And then I'm going to talk about productivity as a commodity. And that doesn't make sense now, but it will make sense at the end of the first talk. So let's go back. Let's start by talking about the three important properties of distributed systems and the teams that build them. So the first one is scalability. I think if you're backend engineers, you think about this daily probably. And for the purpose of this talk, I'll define scalability as the number of work required to get your product serving 10 times as many people, or having 10 times as many users, or encoding 10 times as many videos, or whatever you use to measure scale where you work. Scalability is interesting. There is an adjacent property called elasticity, which is more important at DICE where I work, because our load curves start off at maximum when we release a game, and then they slowly dwindle down. So for us, it's, for example, more important to be able to scale down in the same rate as our customers, even out their playstyle, right? But for most people, scalability is interesting because you might have hockey stick growth if you're a startup. So the next one is availability. We used to call this uptime, right? But uptime makes no sense if you're building distributed systems. And the reason for that is that, if you're distributed, if you run your stuff on 100 servers, if one of them is down, is your product up or down? Are you counting towards your uptime or not? So instead, we talk about this, and we measure this in percentage. So you might have, you might be up 99.9% of the time, and that means that you're answering correct answers to 99 out of 100 queries, right? And the third one is, I should also mention about availability. If you want to compete with Google for this, you should remember that availability includes all your updates, right? So if you're down when you perform your updates, then that's going to count towards your error budget. Count towards your errors, right? So you really need to not miss a single request when you do updates. And if you're going to compete with Google and measure availability, then you're not going to want to miss more than 1 in 1,000 requests, for example. And productivity is obviously not a property of a distributed system. It's a property of the team that builds it. And for the purpose of this talk, let's define productivity as the amount of useful work that benefits your customer versus the stuff that doesn't. So, for example, fixing a bug, definitely, good for your customers. Spending, 2 weeks trying to get that fix through QA and out to your customers, definitely, totally not interesting to your customers, right? So let's go back 15 years to a time where, if you had an iPod, you could be the center of a party. That's definitely not true anymore. And let's talk about DevOps. And how many of you did web application development 15 years ago? Okay. So if you did that, you would have had a development team and an operations team, right? And the general division of labor would look something like this. You would have a dev team, which would channel the business. They would have ideas, they would do software development, they would turn ideas into software, and then they would, have a quality assurance team that would make sure that this was, sound enough to release. And quality assurance at this time were always separate people, not engineers, because engineers couldn't be bothered with, assuring quality, so they outsourced that to somebody else. And then you had the operations team, and what they would do we're going to get into more detail of exactly what an ops team does, but they would do operations, so they would operate your app and your databases and stuff like that. They will handle any live issues that cropped up, so outages, things like that, and they would also deal with infrastructure. So what happened when you wanted to do a release? Okay, so something like this. The dev team would package up whatever they had built, into an RPM file or a WAR file or something like that. And the ops team would have the servers on which to run it. And between them would be a wall, a physical wall, and it was also be, a wall in the process sense, because these were totally separate team managed by totally different kinds of people. And these people would rarely talk to each other on the Friday beer. And so you would toss it over the wall, right? You would take your package and you would toss it over to ops, and now it was somebody else's problem. And it turns out that there were a number of issues with this. In fact, there were many, many issues with this, but I'm going to talk about 2 today. The first one is that when you develop stuff this way, you had to choose between productivity and quality. You had to choose between productivity and quality. And the reason for that is that if you look at software development as something cyclic, then you would occasionally have a release, right? So we would release version 1, and then we would release version 2, and then 3 and 4. And what would happen was that ops would be responsible for everything after we released it. And then, there would be a new cycle of development where the dev team would go into dev and then into QA and then release something again. And the problem with this is that this cycle is going to get slower and slower if you develop this way. And for a number of reasons. The first one is that QA here represents a static cost for every release. It might take QA 3 weeks to validate your release, right? As your software grows, you're going to get more features. You're going to get permutations of features. So QA's work will always increase. So eventually it'll take 4 weeks and then 5 weeks. So you'll add more QA, right, to get that number down. You're also going to figure out, bugs and problems and have outages. And what happens then is that the ops team is going to complain because they know nothing of your product. So they're going to force you to document everything, because everything else that they run, like MySQL or Memcache, everything else had documentation, but not your crappy app, right? Because you just shipped them a WAR file or an RPM or something like that. So they would force you to write documentation, and writing documentation sucks, and it takes a lot of time, right? So that's also a static cost per release. So this is going to get slower and slower, and after a while, if you have enough issues, the ops team is going to insist that you implement a process. And when you start implementing processes, and especially if you start having things like release managers, then you know that your productivity is absolutely going down the shitter, right? So this is why this is going to get slower and slower, and that's why you have. And the reason you have to choose between productivity and quality is because the only reason you can get something through this process fast is by skipping the step that actually validates the safety, right? So that's why you have to choose between productivity and quality. And the second part is distorted incentives. And what I mean by that is that the dev team owns all the risks during development. But as soon as they pass, the release over to ops, they're not concerned anymore, right? They can go back to what's fun, which is greenfield development for the next release. But ops, on the other hand, they now have to deal with this crap that somebody else created. And dev, through the business, has an incentive or a mission to keep the product moving. Because if the product doesn't move, then your business is going to die, right? Ops, on the other hand, doesn't have such a mission. Their mission is to keep the product stable in production. So through the release manager, it actually makes sense for ops not to want you to do releases. So stuff like this happens, right? This is an actual quote for a release manager that I've worked with in my career. So we want to make a process that's so hard to use that nobody will ever want to release anything. Do you think the process? Do you think the business is going to strive if you have people like this in your company? I don't think so. So those were two reasons why this doesn't work. So going back to, I said that I would talk more about what the operations team actually does. So what did an operations team do at this time? Well, they did essentially two things. The first one is to operate your apps and operate databases and stuff like that. And there are three things that are important here. The first one is actually in the word operating. I don't actually know where operations comes from, the word and why we use it, but I'm guessing that it's from the 60s and the 70s when computers were so hard to use that you actually needed somebody to stroke it continuously just to make it, having it purring along, right, while you fed it software. And the second thing about operating is that, and why that is important is because you don't need to do that anymore, right? When you have a MacBook, you don't have a person stroking it. You don't have a person, handling the keyboard that you talk to, and which then does the things you say to do. You can do that yourself, which means that the feedback cycle between you and the computer is much greater, right? So that means that access to hardware has been democratized in a sense. And I'm going to try to cleverly come back to that reference later. But with operations, so a typical thing that the operations team would do, right, is that I could ask them to deploy my app on 10 servers, set up a load balancer in front of it, expose it via www.myapp.com, and tell me when it's done. So the operations team would get cracking with that. They would, set up the machines, set up the load balancer, point the load balancer to the machines, and then a week later they would get back to me and say that, hey, we're done. So it's now up and running, right? And then a few weeks later, one of these machines would break, and then the operations team would be paged. They would figure out, that one of the machines broke. They would remove that machine from the load balancer, find a new machine, install software on that machine, etc., right? That's what the operations team does. Or that's what they do, what you think that they do if you're a developer. Because number two, what they really do is do everything they need to do, right, to support number one. And that can include building data centers, actually ordering fibers to be dug into the ground so that your two data centers can talk to each other, and talking to hardware vendors. There's a lot of stuff that needs to happen before they can actually support your crappy app. So this is the back end of operations, right? This is what happened behind the scenes, and this is the front end of operations. This is what you see, but this is the core. This is the core intelligence when it comes to. This is the core competence when it comes to running an operations. Right. The other thing is the core business that's serving your app. It's like when you go to the supermarket and you buy something, selling you that thing is the front end of the supermarket. The back end is ordering stuff at the correct time and having a massive logistical chain to make sure that you get just enough Cokes on the the shelf so that you can buy it. Right. That's the back end of running a supermarket. So that was, the state of operations in 2003, and if you move forward a few years, things started to change. And one of the things that changed was scale. So about this time, I can't remember exactly when. I think it was in 2007. YouTube was released, and YouTube was the first time you could, read stories in Wired about engineers sleeping next to servers, continuously fixing, performance problems, and using pizza boxes as blankets, right? And so we had a completely different new scale. You'd had a scale where even if you went and bought the absolute biggest server you could find, your MySQL would still not fit, right? And that had never happened before. There was always more RAM to purchase or more hardware to purchase, but suddenly that wasn't enough anymore. We also wanted to move faster. So imagine if you are that, YouTube engineer fixing performance bugs. It's not like you're going to want to wait 4 weeks for QA to verify your performance fix unless you release it, because you have hockey stick growth, right? You had twice as many users now as you had a week ago. So you need to be able to release things fast. But at this time you couldn't do that safely. So you had to choose between safe or fast, right? And the third thing was actually that we started to realize that there is a difference between building, spending 2 years holed up and building the next version of Microsoft Office and then releasing it. There's a difference between that and releasing a new version of your web app every week. So perhaps we can do things differently. And the major difference between them, and this is something you absolutely need to understand, the major difference is that when you build Microsoft Office, you're going to spend an incredible amount of engineering hours before your initial release. So before the initial release, right? And then you're going to spend a very small amount of hours after release. So for example, the same is true in the games industry, right? You have hundreds of engineers working on a game, and then you release it, and then you're going to have a skeleton crew running patches. So the majority of your interaction with developers is going to be spent before the first release. So it makes sense to optimize your developer tools and your developer experience for that period. So, for example, if there's only one person in your team that can build a release, perhaps that's fine, because if that person is ill on a Friday, you just build the release on Monday, right? Because you're going to build a total of 6 releases in your life. And it doesn't matter if the static cost of testing your new release is 4 weeks, because you're only going to do it 6 times. However, if you're building YouTube, then it's the opposite, right? You're going to spend perhaps a few days of development before you put something online. And the rest of your deploys is going to be done towards the production environment. And you're going to be doing 10,000 releases over the coming years. So you can't, spend 4 weeks validating every release. Perhaps you can spend 4 minutes validating every release. And you can't have a single person who knows how to do the build, because you release 10 times a day. So if that person is ill, then you're not going to be able to deploy that day. So that's the difference. And if you do that, then it makes sense to optimize for that, right? Continuous integration, continuous deployment, DevOps. That's why we have them. So let's talk about what happened at Google during these past 15 years. I'm not going to claim to know everything that happened at Google, and what I'm going to tell you might not even be true, but this is the way I interpreted it. So how many of you know what site reliability engineering is? Okay. So site reliability engineering is what Google essentially called the newborn ops, right? It was ops 2.0 essentially. And the major difference between an SRE and an ops engineer is that an SRE is an actual software engineer. So the SREs are people who are very talented software engineers, but they also know a lot about operating, stuff on the internet, essentially. Whereas ops engineers, usually a lot of them didn't know how to. They couldn't do software development, right? They could do basic Ruby or Python because they did some small, automation, but most of their work was actually manual. So the thing about SREs is that if Dev and Ops had a relationships where ownership of an application would slowly shift towards Ops, then the idea with the SRE was instead to have them live side by side. So the point of the organization at this point was not to run applications for developers, but to create tools and processes so that developers could run their own applications, but in a safe way. So the tools need to be good enough so that you can run your applications, in a safe way. And let's not only talk about developers, let's talk about entire product teams, right? So what happens if you do stuff like this is that the incentives we talked about earlier looks a lot better now, because now developers are responsible for running their stuff in production. So if previously developers didn't know how production looked, they're now going to have to be intimately familiar, right? I can't find it anymore, but there is a great quote on Twitter from somebody who said that production quality in an app skyrockets after you put a pager in the hands of an engineer, right? So as soon as you have to support your own shit, then production quality is going to go up, and your software is going to get more resilient, right? Because nobody wants to be woken up. But if somebody else is getting woken up, then you might not care. But the purpose of the SRE and the purpose of the new organization that Google built was to enable developers, to make the developers more productive. Because when I talked about democratizing hardware, right, and the fact that when you use your own computer instead of going through somebody else, because you're going to get a shorter feedback cycle, and that's exactly what happens here as well. If you allow developers to send stuff off to production and see what happens, and then send it off to production again, then the feedback cycle from developer to production is going to get a lot shorter. And we're going to talk about iterations later, and why that equals quality. But this was the idea behind the SRE. And if you want to know more about SREs, if you do backend development or distributed systems, then you should definitely read Google's book about the SRE, and it's free. So there's really no excuse not to read it. So one other thing that Google did, so when I say help developers do things safely, another thing that Google did was something I don't know if there's a term for it, but I call it expertise as a service. And what that means is, if you have a very skilled database engineer, for example, there are two ways you can use that person. You can either have her set up every database that your organizations need, or you can make sure that person takes what she knows and makes software out of that, right? So if that person is an engineer, then that person can create a service that set up a databases for you whenever you want it to. And if you do that, then eventually you end up with something like Aurora RDS on Amazon Web Services, right? Or Cloud SQL at Google, a service which runs databases for us. And that obviously, software scales a lot better than humans, right? And if you create a service that sets up MySQLs for you, then other people can patch that service if it happens that sometimes it makes the wrong decisions. And at Google, how many of you know what Kubernetes is? How many of you use Kubernetes? Okay, so I'm going to explain what Kubernetes is. But when we're talking about expertise as a service, Kubernetes is definitely the prime example, right? So if you don't know what Kubernetes is, it's a service that runs apps for you, essentially. So what you do is that you install Kubernetes, and then you give it access to a bunch of hardware. For example, you can give it access to 10 machines, each of which has 32 cores and 64 gigs of RAM, and now suddenly you have a cluster of 320 cores and 640 gigs of RAM. So what you can then do is that you can tell Kubernetes that I want to have running a service called My App, and I want it to have 10 instances, and I want you to put a load balancer in front of it, and I want you to expose it behind www.myapp.com. Does that sound familiar? Yeah. And what Kubernetes will do then is that immediately it's not going to do anything, because the way Kubernetes works is that once you put that request into Kubernetes database, it's going to periodically look at what it's supposed to run and what's actually running in the real world. So it's going to take a look, and it's going to see My App, 10 instances, and it's going to check the real world, and in the real world it has 0 instances, right? So it'll start off by starting 10 instances. It's then going to see that, okay, we're supposed to have a load balancer, but there's no load balancer created. So we're going to create a load balancer, and we're going to point it to those 10 instances. And then after a while, everything is set up, and it's going to report back to you and say that my app is now running. And if it took a week for the ops team, it's likely to take under a minute for Kubernetes, right? The same happens when one of these machines disappears, goes down, is destroyed. Kubernetes is going to react, and probably within a few hundred milliseconds, it's gonna move, move stuff off the broken machine onto working hardware, and nobody has to be paged because Kubernetes does it all the time, right? So in fact, when you run something like Kubernetes, it's nice if you drain hosts before you take them out of service, but you can also just yank the power because Kubernetes is just transparently going to move your load someplace else. And Kubernetes is expertise as a service, right? Kubernetes is essentially all the expertise that Google has in running apps is encoded into Kubernetes. And Kubernetes is open source, and it has thousands of contributors. So a lot of other people who are also really smart is contributing to Kubernetes. And Kubernetes, when I talked about front end and back end when running operations, Kubernetes doesn't replace the front end and the back end, but it does replace the front end, right? So Kubernetes is expertise as a service, and Kubernetes is designed to be used by developers. And Kubernetes is a typical piece of software that enables developers, because any developer can day or night tell Kubernetes that I want something running, and Kubernetes will gladly oblige. You don't have to create a ticket, right? You don't have to wait until Monday for the ops team to come into work in order for something to happen. So now I'm going to talk about something called App Engine. So how many of you have you heard about Google App Engine? Have you used Google App Engine? All right. So I'm briefly going to tell you why App Engine is essentially the best thing that has happened to software engineers. And the reason for that, and the reason I call it the pinnacle of productivity, is because Google App Engine was released in, I think, 08 or something like that, 09, right? And Google App Engine is three things. If you don't know what it is, it's three things. First of all, it's an SDK. And it doesn't say SDK, but you'll figure out why soon. It's an SDK that allows you to build web applications, right? So it has support for the normal stuff that you'd need when you write a web application. So handling incoming HTTP requests, and answering with HTTP responses, handling static assets, writing and reading from a database, accessing memcache. Emitting events, responding to events, cron jobs, this is essentially the standard stuff. But there's one major difference between this and everything else that was available in 08, and that is that what the web SDK was rather limited. The Google App Engine SDK was rather limited. So what happened was that when people would look at the SDK and compare it to something like Django, which was popular at the time, they would say that this looks very, very limited. I think I'm going to stick with Django. But the reason it was limited was because what this SDK did was it would draw a box on the ground, and it would say that, so this box is pretty small, right? But as long as you stay within this box, I'm going to guarantee you that you will get scalability and availability. So as long as you stuck to the Google App Engine SDK, then Google could make sure that your whatever you built would scale and would be essentially always available. And that's pretty magical, and that's why I write constraints, because that's for me that's one of the most important parts of a good SDK is constraining you and guiding you towards doing the right thing. So the second thing it allowed you to do was to build and iterate locally. So I mean, you would download the SDK, there would be a runner, it would fake, there would be a local database, you could do local development, etc., etc. But the thing is that you never needed to care about anything other than actually building your application. The third thing was that it allowed you to run your app. So what you could do when you were done with your application was to click, a play button, and it would upload your application to Google server, and it would run your application for you, and it would auto scale your application depending on load, right? It would set up all the databases you needed. And it would even give you dashboards where you could see, important metrics on your application. So essentially, this is everything. I mean, if you use Google App Engine, you're going to be close to as productive as you can be as a developer. Because remember that when you spend your time setting up a Prometheus instance or configuring Grafana, you're not creating value for your business, right? But if you were to build your stuff on Google App Engine, then you would constantly be building value because there would be literally nothing else to focus your time on, right? The reason we didn't use it was because it was too expensive. So once you got up to scale, Google App Engine would be too expensive, and there was no viable way to migrate off Google App Engine, at that time. So people didn't use it. It was essentially, relegated to being used for hobby projects. But I should mention that today there actually is a path away from Google App Engine with Google Cloud. So if you're thinking about, seriously, if you're thinking about building a backend for your iPhone app at your startup, I can highly recommend Google App Engine and Google Cloud in general. But if you want to stay as productive as possible, you shouldn't be messing around with, for example, AWS and setting up machines or Beanstalk or whatever. If you want to be as productive as possible, then this is where it's at. So you might ask yourself, can't I piece together, a million open source projects and manually try to glue them together to achieve the same results? And you probably can. And if you're the size of, Google, then it probably makes sense to, build your own stack to achieve the same thing. But in all likelihood, you're not going to be as big as Google. Yeah, productivity. Also, regarding open source, I mean, Google App, and I use Google App Engine as an extreme example of what's happened in the past 10 and 15 years with regards to availability and scalability and productivity. But there is also obviously other things that has happened, right? So you have stuff like Skylla and Cassandra and Riak, Kafka. So there's a lot of technologies out there that essentially makes it very, very easy to achieve scalability and availability nowadays. Productivity is a lot harder, and I'm going to talk about that more. But I would argue that this is a revolution for developers. Having access to availability and scalability, and DevOps and self-service team, self expertise as a service, that is a revolution for developers. But it's not a revolution for operations people. So if you're trying to introduce DevOps at your company and the operations people are not impressed, then it's simply because DevOps is not for them, right? DevOps is for engineers. Because the ops people have always known how to operate something so that you can have it available and scalable. They've always known that. So for them, this is nothing new. Okay, so availability and scalability. We could argue by virtue of Google App Engine that this is available to anybody right now. So anybody can go out, create a backend, and it will be available and scalable. So we can I would argue that access to these properties has been democratized, right? Anybody can access them, and that's great for productivity because what we're doing as developers is channeling the business. And if you can do that in a way so that your stuff is available and scalable, then that's awesome. So what about productivity? So that's actually the end of my, do you guys want to have a break? No, you don't? No, let's skip the break. So productivity as a commodity. Okay, so I think I've established now that, we have availability, we have scalability, and the third thing I talked about was productivity, right? If you think that you are productive right now, but you want to increase your productivity because you have engineers that you've hired from Google, and you're starting to realize that they don't feel as productive as they did at Google, then there is a holy trinity of sorts of techniques that I think that you should be aware of. But before we talk about that, I want to talk about something called ecosystems. And I must say that when I heard, the Klarna people talk about the kinds of backend engineers that they were hiring, they weren't only talking about Java, right? They were talking about multiple languages, which actually made me very happy. The thing about ecosystems is that normally when we talk, for example, about different kinds of backends, what we usually talk about is programming languages, right? So you heard the Klarna the Klarna recruiting people talk about different languages that they wanted to hire. But the thing is that language is essentially the easiest part, right? Because this is everything else that engineers deal with. So it's what SDKs do you use? What IDE do you use? Where do you store your source code? How do I submit changes to that source code? How do I write tests? How do I compile whatever I built, right? How do I launch it? Where's the issues stored? So this is what you deal with when you're an engineer and you're trying to make your product go forward. This is all the stuff you have to know. So imagine this case. Imagine the case of a front end and a back end at your company, right? And they look pretty dissimilar. They don't look similar at all. So if you do both backend and frontend, you're going to have to deal with two ecosystems at all time, and it's very likely that you only know one of them. So let's talk about a front-end engineer. Let's talk about a front-end engineer here who uses this backend system, and the only language she knows is JavaScript. She's never touched the backend, never seen a functional language, never touched Scala, right? And she uses a new API, and it's supposed to return 10 items, but it only returns 9. So it's likely that there's a small, off by one error somewhere in the backend, right? So what she does is that she doesn't know how to run the backend, but she does know where the Git repository is. So she takes a look, and it turns out that since the method she's calling in the backend, it's pretty easy for her to find that particular error. Because even if you haven't seen Scala before, I can pretty much guarantee you that you will be able to find an off by one error if you know approximately where to look. So she finds that, she changes one number, which is likely to fix the problem. But the problem is that she has no idea how to use SPT. SPT isn't even installed on her machine, right? And even if it was, she has no idea how to add a new test to verify her fix. And she has no idea about all the other stuff. She doesn't have, the IDE or the plugins installed. She doesn't know the SDKs. So the problem is not going to be the language. The problem is going to be the entire ecosystem. So what happens instead? So what could have happened is that she could have fixed this bug and submitted it, and she could have moved the entire company forward. But what instead happened was nothing, right? Instead, she has to file a bug with the backend team, and that's gonna have to go through a ritual where people sit around a table with cards with numbers on them, and 4 weeks later it's gonna be fixed, right? Which means that she can then go back to the bug that she initially had to fix. So the lead time for her fixing her bug was something like 6 weeks, and it could have been a day. So that's ecosystems. And the thing with ecosystems is that transiting them is very, very costly. And it doesn't matter what metric we're talking about. It could be onboarding onto a new ecosystem, very, very expensive. Transiting them via APIs, very, very expensive. Moving back and forth as an engineer, probably expensive. Synchronization costs for the projects, for the backend and the front-end team, extremely costly. You having to keep the backend and front-end team in lockstep at all time for every feature you build, extremely costly. So ecosystems are very, very bad. And I'm going to talk about two things about languages. So the thing about languages is that you often hear about companies like Spotify or Klarna, for example, where they have every team can choose what language they want to build their backend in, right? We use microservices, we use Thrift for communication, so now every team can choose whatever they want to. So some team chooses Rust, another team chooses Go, somebody uses Scala, somebody uses Java, and that's great if you're a CTO who wants to be everybody's buddy, right? The problem is that now you have a lot of ecosystems, and that's bad. That's a horrible idea, right? But you might also do something like I've heard that Spotify and Klarna has done, which is to try to standardize on one language, such as Java, right? And that's also a horrible idea. Because the reason is that it's incredibly unlikely that all your engineering needs are going to be met by Java. Incredibly unlikely in a company like Spotify and Klarna. So what are you supposed to do then if you don't? If you can't have multiple languages and you can't have one language? But that's not what I said, right? I said that you shouldn't have multiple ecosystems. So what you can do is use something like you can have a build system which you can use across all languages, right? You can have a build system that understands your front end and your back end, and can build your iPhone app and your Android app. You can have one build system that builds everything. So an example of such a system is Google's Bazel, which is an open source version of their internal system, which I think is called Blaze internally at Google. But at Google, you're likely only to be exposed to one single build system, no matter what technologies you use, and that's Bazel. So what Bazel can do is essentially four things, right? It can compile something, it can test something, it can run something, and it can answer queries about the relationship between your projects. So, for example, with the front-end thing I described earlier, that front-end engineer could simply she would have known how to compile the backend, and she would have known how to run the tests, and she would have known how to run the backend once she had fixed everything in order to verify her fix, because it's the same tools that are already installed on her laptop already. And an even better example, I think, about moving an entire company forward instead of creating additional work is if you think about a shared library developer. So imagine that you're a shared library developer and you have 5 internal users of your API, right? So you want to make a breaking change to your API. And the reason you write this shared library is because you're the expert at this domain. So what happens normally when you do a breaking change is that, according to semantic versioning, you're going to have to deprecate it, you're going to have to write documentation on how to migrate, and you're going to get to, to try to get everybody to understand. And 7 months after you do that, somebody's going to, come along and be pissed because you finally removed the method that you told them was going to be deprecated 7 months earlier. With Bazel, what you can do instead is that when you make your breaking change, you simply tell Bazel to find every user of you and compile them. And it turns out that it wasn't 5, right? It was 10 usages of your library, 5 of which you didn't know about. And Bazel would try to compile them all, and they would all fail, right? But now you have a list of all the places that uses your new that broke when you made your change. So you find them and you fix them, and then you ask Bazel again to compile everything, and it now works. You can now run the test. You can tell Bazel to run the test of everything that depends on me. And Bazel would do that, and everything is green. And now you could, submit pull requests to all the users of your library. And what happens now is that now you've moved your entire company forward because everybody is now on the latest version of your library, but you haven't caused any additional work to anybody. So that's how you become productive, right? This is, if you want to go from, 50% to 80% productivity, you're going to have to do stuff like this. Because you can't have engineer continuously causing additional work to other engineers. Because then you're never going to be, fully productive. Okay, so I said that when this shared library developer is done, it can create pull requests to everybody, right? What you really want to do is something like this. You want to have a monorepo. So you want everything, all the software in your organization, you want that to be in a single repository. And you want that to be in a single repository so that changes can be tracked together. So for example, when that shared library developer made some changes, you want the library change and all the software, all the users, you want that all to be in one single commit. So you want that entire update to be one object, which can be managed and versioned and especially reasoned about. Yeah, so you want to put everything in the same repo. This is the way Google does it. For example, this is the way Facebook does it. A lot of companies that have very productive engineers do it this way. And it's very likely that the Git is not going to work for this. This may sound like a very strange concept, but as I said, if you want to go from like 50% to 80% or 90% productivity, then you're gonna have to go with a monorepo. Bazel, for example, is also optimized for. I mean, Bazel is built to be used with a monorepo. And that's because what you can do in Bazel is that you can have the entire build tree of every application at your company. So you can have Bazel track all the 10,000 things that build, right? And Bazel will have a tree. I should mention something else about Bazel, by the way. Bazel is also fully predictive, which means that for a given set of input, you would always get the same output. And the advantage of that is that it's cacheable, right? So if you spend a lot of time compiling stuff, especially compiling other people's changes, then Bazel might be incredibly interesting because you're only going to have to compile something once. Running tests is also predictive. So if I make a change that forces me to rerun 4,000 unit tests, then you're not going to have to run those tests because the results are cached, right? And as soon as if you don't touch anything that's covered by those tests, you won't have to run the tests again. So that's also how you become productive, right? When you don't have to compile stuff needlessly. So monorepo, probably not Git. If you're serious about looking into it, I would probably suggest Perforce. Perforce is not, optimized for. I think we're gonna see the release of a new. Source management system that is fully compatible with Bazel. I'm not sure if Google is going to release whatever they have, but somebody's going to do it pretty soon. And the third pillar, or the third side of the triangle, is hyper-integrated tools. So this is look at the Google App Engine, for example. Google App Engine makes you very productive because it's not generic. Google App Engine can't push your code to Amazon Web Services or your local server or a Raspberry Pi, and because of that, it can you can get an incredibly tight user experience, right? So and that makes it a lot easier to be highly productive. So if you want to have your internal tools team compete with things, you should not have them compete with commodities, right? You should not have them trying to create an alternative to Grafana, or trying to create an alternative, to Kubernetes, or perhaps not even run Kubernetes, because then you're competing with the commodity stuff. What you should do is, on top of the things that the open market can give you, you should be building hyper-integrated tools that tie all of the stuff that you and only you do together, so that you can deploy with a press of a button, or automatically create a Grafana dashboard whenever you create a new repository, something like that. Tools that are built specifically for you, perhaps for one department only. And that's also how you go from like 50% to 80 or 90% productivity. And there's no way around it. You're gonna have to invest in tools like this if you want to reach that kind of productivity. And to talk about, I mentioned, being specialized and generics and commodities. And what I want to share with you an example, because I hate generalization, right? I hate abstractions, and I hated being a Java developer when the normal way to solve a problem was to add another layer, right? Abstractions. I think they totally suck. I hate abstractions, and the reason is something like this. So if you're a junior engineer, or a product manager, or something like that, Scrum Master, you might look at these two and you might say that, well, I mean, to be honest, both of them have like 4 wheels, right? And both of them has like a steering wheel, and a gas pedal and a brake pedal and an engine. So couldn't we, just have one that does both instead? And the biggest problem with that, the biggest problem with replacing, a sports car and a truck with a single vehicle that's supposed to do both, is that, it's actually going to work. That's the biggest problem. It's just that you're going to be really, really unproductive when you use that vehicle, right? So be aware of abstractions even though they work, because the fact that they work is not an indication that it was the right thing to do. Abstractions is almost always the wrong thing to do, right? Unless you're building something like Grafana where you have to support 10 different types of metric storage. But the fact remains that if you use Grafana, and the Grafana, we use Grafana with Prometheus. Great product, by the way. If you use Grafana with Prometheus, and Grafana had been written specifically for Prometheus, our productivity with Grafana would go up a magnitude, right? But I totally understand why they don't do that, because not everybody uses Prometheus. So that's totally fine. It's just that you should avoid abstractions at all costs. And you should, if you're going to have a tools team, have them create hyper specialized stuff and never compete with the open market, because you're gonna lose. So those are the three the three pillars that you should be aware of if you want to increase productivity. And the thing is that productivity. Let's talk a little bit about what I actually mean. So, okay, so scalability, availability, productivity. So what's the point? What's the point of this talk? But the point of this talk is two things, three perhaps. Number one is to try to inspire you, right? To show you that it's actually possible to get all of these properties, and the open market has solved that for you, right? So if you're not scalable or highly available or productive, then it's fully possible for you to become so. The second point is to act as a warning and an eye-opener, because if you're not productive or highly available or scalable, then the thing is that all of your competition, especially those who are starting out today, they get this for free, right? If you start off on the Google Cloud platform or start off using Scylla as your first database instead of MySQL, then you're gonna get a lot of these things for free, and you're gonna start running essentially. The time where it was a competitive advantage to have a large internal IT team is gone, right? Now it's a competitive disadvantage if you have a large legacy IT team internally. So I said earlier that we were supposed to talk about iterations, and this is it. I want to know if anybody disagrees with me when I say that the more iterations you have on whatever feature you're building, the higher the quality it's going to be, right? So the more feedback cycles you have when you build something, the higher the quality is going to become. Does anybody not agree with that? Okay. So let's talk a little bit about, because the thing with productivity is that I've noticed that when I talk to people about productivity, they assume that everybody else's productivity is about the same as their own. So if you mingle later, my 7-month-old son is with his babysitter, so I'm going to have to run after this talk. But when you mingle later, compare your productivity, right? Talk about your productivity, because you're going to notice that there's going to be an enormous span between how productive you are and how productive somebody else is. But nobody understands that. I find that most people think that well, everybody is about as productive as my organization, and they realize that there might be, well, somebody could perhaps be 25% more productive as my organization. But I'm going to show you some numbers about how big that span actually is. So these numbers are from Puppet Lab's State of DevOps, which was released early summer, something like that. And these numbers compare ineffective organizations versus effective IT organizations. So effective organizations make 44 times as many code deploys as an ineffective organization, right? That means 44 times as many iterations in production, 44 times as many feedback cycles on which you can act to improve your quality, right? This is how you become productive, right? Having 44 times as many, if your competition has 44 times as many feedback cycles as you are, then you're going to go out of business, in a few years, right? They have 440 times faster change lead time. And change lead time is the time, the time it takes for you to build something and then deploy it in production. So that means 440 times. That means that if it takes you 15 months to get something out in production, it might take your competition 1 day to get the same thing out in production. 15 months versus 1 day, right? recovery time almost 2 magnitudes. Recovery time is, recovering after an outage, or recovering after an outage, or fixing a bug, right? So almost 2 magnitudes faster recovery time. I mean, that's 10 days versus 2.5 hours. And people sit and think that people are about the same productive, have the same level of productivity or can react in the same speed as you can. But that's not true, because some organizations can react 2 magnitudes times faster than somebody else. 1/5 the change failure rate. And the change failure rate is the amount of changes you make that end up causing problems of some sort. So you could actually reduce that by 80%. By becoming a more effective IT organization. And becoming an effective IT organization, you should read the Puppet Labs report yourself, but that's essentially adopting DevOps, right? It's having tools that makes it safe and fast for your developers to push things into production. It's replacing a release manager with a bot. It's stuff like that. I should also mention this if you're interested in DevOps. DevOps and Agile are essentially 2 sides of the same coin. You can't have one without the other. And when I'm talking about Agile here, I'm not talking about the rituals of stand-ups or sitting in a room discussing dragging and dropping in Jira. I'm talking about continuous learning, and I'm talking about teams that are autonomous. And can decide for themselves what to do, and teams that are not tightly coupled to other teams. So if you have an ops organizations and you do ops via tickets, then you are definitely not agile, right? If your developers can't perform their own releases, then you're not agile, right? And DevOps and Agile, they coexist, and essentially, I mean, I'm guessing that they will merge at one point, right? Because Agile is software development and DevOps concerns software development, so perhaps it's the same thing. So if iterations is quality, then DevOps and Agile is quality. So if you ever end up in a discussion about Agile and DevOps and why you should have it, you should not stress things like reducing costs, for example. You should stress things like surviving the next 5 years in competition with your competition, and increasing revenue by increasing quality, stuff like that. And that's actually, the end of my talk. Obviously, we're hiring not only C++ game people or technical artists. We're actually, we're hiring ops people. We're hiring front-end engineers, JavaScript people, back-end engineers. So dice.se/jobs if you're interesting. Well, interesting as well, but also interested. So, are there any questions? Yeah, you need the thing.
Oh, the other thing. Hello, thing. My question is, what do you think about AWS Lambda / Google Cloud Functions? Is that something that you think is not interesting, or is it some kind of relation to your App Engine kind of position?
So I haven't used Lambda or Google Functions. And I also have a hard time seeing where I would use them, especially when it comes to source management. That's my biggest issue with Google Functions and Lambda. But as I said, I haven't used them.
Question? No more questions? Is the thing? Question.
Hi. I was wondering about in the monorepo scenario.
Yep.
You mentioned that you could actually detect tests that would be affected by a single change in the repository, so that you could cache the results of the tests.
Yes.
Can you elaborate on that?
That was, I think, in the monobuild section. But yeah, I mean, so are you asking about caching tests? Is that?
I have a single repository, whatever I'm using, with 2,000 tests in there.
Yep.
I'm changing a line of code, and I want to know what tests are affected by that change automatically, so that I can cache the results of the tests. That's what I understood.
Yeah, so there are 2 parts to that. The first part is figuring out what what depends on you, right? And that's if you use Bazel, for example, you can ask Bazel because essentially your entire all of your builds is a graph in Bazel, right? So you can and there's a query language for querying that graph within Bazel. So if you have you know, an entity, a node in that graph, and you have other things that depend on that and which have tests, then you can ask Bazel, you know, essentially what depends on me. Run all the tests that have some sort of dependency to me. The second part of the answer is about caching and caching tests. And the thing about which I should mention about Bazel and tests is that Bazel is not going to cache if you have an entity in this graph which has 1,000 tests, then Bazel is going to cache all of those tests as one bunch, right? So it's not going to be able to cache the result of one single test. But the invalidation is at, you know, the entity level in Bazel essentially.
Is it like who defines the dependencies can be automatically detected? Because from what I don't know Bazel, but you said that you can basically have your applications in different languages and stacks and everything.
Yep.
And you can basically, you have to express dependencies.
Yes.
So it's the developer itself who express this depends on something else.
Yes.
Which could be error prone. So I could miss a dependency there.
Well, if you miss a dependency, then you wouldn't compile. So I mean, yeah, it will become special when you have things like when you have things that integrate runtime, right? So I mean, I'm a backend engineer, so most of the stuff I build will integrate and check at the compile time. But if you have stuff like JavaScript that you integrate runtime, perhaps that will be harder to solve with Bazel. But it is being done at Google.
I see that despite my initial fears, we do have some kind of tequila going on here. So one last question before tequila.
I'm going to keep it quick. Why don't you like Amazon Web Services?
Did I say that? So it's not that I dislike Amazon Web Services, but it's just that I'm a very big fan of. I mean, these are my personal opinions. We use Amazon Web Services a lot, and it works really, really good. But if you're talking about productivity, then the thing with Amazon Web Services is that they are not coupled as tightly as Google's services in Google Cloud is. In Google Cloud, you can get an increasing value simply by using more products. So Google, for example, I mean, if you store things in a database in Google Cloud, then it's going to be very easy for you to get that data into BigQuery, which allows you to ask questions about potentially terabytes of your data with a response time, a P95 response time to your queries of like 5 seconds, right? In Amazon, you're going to have to do a lot of the gluing yourself. Both of them are solid, right? It might be a matter of preference, but for me, I like to do as little gluing as possible.
Since we are sort of out of time and we have a time budget, please don't lose this guy. Keep on track of him, and please give him a nice and warm applause.
Thank you.